We're going to start it in class today, and you guys are going to have all of Friday to work on it. So this isn't necessarily something you need to do at home. We have like an hour and 45-minute class period on Friday that you have to work on all of this, okay? So with this project, what you're going to do is you're going to collect a bunch of actual identifiable data from your peers, and you're going to create a real scatter plot, and then we're going to do a couple of things with that scatter plot, okay? So, can I get a volunteer to read this first thing for everyone? Yeah, Alex?
Come up with two sets of data that you want to compare, making sure it's something that your peers and our family will be able to give accurate, credible data about.
Perfect, absolutely. So, I know it says and or families. Most of it's going to get done in class. The focus today is going to be for you guys to figure out what are your two sets of data that you're going to be comparing. We'll talk about some examples in a second. You're going to write a background statement outlining the two sets of data. Very simple, as you'll see. You're going to make a prediction about your data, predict what type of trend you're going to see, positive association, negative association, no association. You're going to collect data from 30 individuals. There's 36 people in class, so we could technically do, everyone could do it in here. Whatever it is that you pick, and you're going to write all that information on your table of values, okay? Once your data has been collected, you're going to set up your graph and plot all your points. You're going to identify the trend. You're going to find the mean, median, mode, and range, as well as the standard deviation for whatever your independent variable is, which is x. Then you're going to write a quick little summary, figuring out what did you discover from this. Interpret what the standard deviation means. We just talked about, like Anthony helped us out with, a low standard deviation means that we're close to the mean. What does that mean? Mean. And then whether your prediction was right or wrong, right? Grading rubric, you can see that later. Here's what it's going to look like, right? So I will be exploring the relationship between, let's look at my example. So the two things that you have to decide on are, they have to be numbers, right? You can't say favorite color and age, because how do you plot favorite color on a graph? You can't, right? So for my example, I went with height and shoe size, right? Do you guys think height and shoe size have some sort of relationship? Yeah. Probably, right? I predicted that the taller you are, the bigger your shoe size. Right? So my background statement, nice and simple, just the relationship between height and shoe size. My prediction, what relationship do I think those two quantifiable data points have, right? Now, could I do height and age? Yeah? Why? Because age is a number? Yeah. Give me a thumbs up if you're 14. Give me a thumbs up if you're 13. Okay, raise your hand if you're any other age but 13 or 14. Okay. Probably not a good idea to use age then, right? Because you're only going to have 2 points on the x-axis, one for 13, one for 14. Not going to work. Now, if you were going out in the world and finding random people, age would be a great one to use. But because of the confines of this assignment, you should not be using age, okay? Some good ones that I've seen from students in the past are like your GPA and your hours of screen time on your phone each week, right? You can go on your iPhone or whatever phone and pull up how much hours you spend each day on your screen. That might have some relationship with your GPA, right? Another one I saw was number of tardies and GPA, right? The more tardy you are or the more absent you are, maybe the lower your GPA, whatever the case may be, right? But the two things you're comparing have to be numbers, and they have to be numbers that you as the data points can like prove, right? So if I go up to Aaron and I'm doing this, right? And I say, all right, Aaron, what size shoe do you wear? And you say 9.5. And then I say, how tall are you? And he says, I'm 6'7". I'm gonna go, you're probably not 6'7", right? So the data has to be accurate. I can't just be making stuff up. That defeats the whole purpose of why we're doing this, right? So then you're going to get your table of values. X represents my height in inches. Y represents my shoe size. Here's all the data that I collected. Okay. So all the people's heights over here, all their shoe sizes over there. Now, because I just made all this up, you guys are actually, you have 30, I don't have 30 people to talk to. I don't even know 30 people. But you guys will ask each other all this information. All of my Y values, you notice they're in order, right? Your data is not going to be in order when you're putting it in this table. It's going to go all over the place. So it might be something you need to reorder later on, but not really, because now after you have all your table filled out, you've got 30 unique points that you can then plot on your scatter plot like this, right? So all that data you just saw gives me this scatter plot right here. Everybody see that? So if I look, right, whenever I get my data, I got to figure out what's my range. So my height ranged from, that's how I wrote it right here. For my x-axis, my highest, or my tallest person was 76 inches. My smallest person was 59 inches. So my range would be 17. There's 20 little notches on my x-axis, so I just went by 1 inch for each little notch, right? Then my y range, my highest shoe size was 13, lowest was 5.5. That's a range of 7.5. If I have 20 notches, now I'm going by 0.5, right? So you have to figure out what scale is going to work after you've collected all your data. Because if I did every notch was one shoe size, 5, 6, 7, 8, 9, 10, 11, 12, 13, well, now I'm not utilizing this whole top section of the graph. You see that? So you want to make sure your scale is spread out for the x and the y. And then I plotted all my points. What type of association does this look like? Positive, right? Because it's trending up, which means as my height increases, what happens to my shoe size? Also increases. That's a positive association. I can conclude this is a positive association. Now, you might not get a clear positive or a clear negative. What would my association be then? No association. That's right. Some of us on the test put undefined association, random association. The correct answer would be no association. All right. Then I'm going to take all my data and I'm going to analyze it. I'm going to find the mean. I'm going to find the median. I'm going to find the mode. I'm going to find the range for my x, whatever my x is. Okay. So the mean height was 67. The median was 68. Mode, the most frequent was 70 inches tall. And then my range was between 17 inches, right? So then I take all my data points. I put them all in order. I find the mean, right? That's right here. I take my data point minus the mean all the way down. I square it all the way down. Same thing for all 30 points. This is probably going to take the most amount of time, I would assume. Right? What's that? You said this is the final? Oh, you'd rather take a final than do this? Are you guys serious, bro? You're tripping. Well, I don't think it's more tedious than final. Once you guys actually do it, you'll see it's not that bad, okay? Keep in mind, this is what I normally give to my Math 8 students. Are you saying that you guys are not capable of handling something like this? Okay, that's what I thought. So you get all this, you find the mean of the square deviations, you take the square root, boom, there's my standard deviation. 4.37, relatively high, relatively low. Pretty low, right? It means my data is mainly clustered around the mean. My mean is 67. If I look back at my graph, right, well, here's 67. Not only do I have multiple data points there's 2 there, there's 1 there, but I see that I've got a nice big cluster right over here near my mean. That should result in a smaller standard deviation, right? Once you find the standard deviation, you're just going to write a summary. Here's my summary. I observed that my prediction was accurate, as the positively associated scatter plot showed. Typically, the taller you are, the larger your shoe size, right? My standard deviation was 4.37, which is fairly low, meaning that my data was closely centered around the mean of 67 inches. I'm not asking you to write a 5-paragraph TEAC essay, right? 2 sentences max. That's 15 points worth of the 50 right there, okay? I've had some people come up and concerned about their test that we took yesterday because there's no opportunity for corrections. If you do poorly on the test, but you do well on this, everything balances out. Does that make sense? And if I give you 2 tests and you do bad on them both, it's not going to balance anything out, right? So this is to help you. You may find it annoying. That's fine. That's your opinion. But ultimately, it is to save your grade if you are on the brink. All right? What questions can I answer about this? Yes?
Okay, so like the things that we're choosing to pick data about, can it be something that is obvious what the answer will be?
Like what?
Like how many rich points are in your account?
Oh!
To how many things you've used it on?
That's a good one. I think you could do that. Because everyone can go in and check how many rich points they have, right? And you can check how many rich points they've used, right? So what relationship might there be between the amount of rich points you have and the amount of rich points you used?
It'll go down the more you use.
So the more rich points you have,
Like,
the less you've used?
no.
Oh. That would make
You
sense
have
though.
Less rich points the more you use. Like, oh wait, yeah, you did say that.
Yeah, that would be a straight line, I think, is what that would end up being. So what I would do for that instead is I would say your total rich points earned versus how many of those points you've spent, right? So not how many you currently have, but how many have you earned the whole year? It tells you that too. Because then there might be the more points you've earned, the more you've used because you have more points to use, or you might see the more points you have, the less you've used because people stockpile their points and hoard them. It could go either way. That's a really good one to use. Great question. Any other questions? I know questions are going to come up as you guys are working through this. Right now, the focus is coming up with what two sets of data you want to compare. Before you start, listen up. Before you start getting up and asking people and bothering them about how tall they are and all that kind of stuff, you need to get your background statement signed off by me. Okay? So when you come up with what you want to come up with, right? Obviously don't use height and shoe size because you just saw that whole example. You can use height and something else. You can use shoe size and something else. That's totally fine. Just don't use height and shoe size, all right? Once you think your background statement is good to go, bring it up to me or raise your hand. I'll come over and sign off on it. Then you can make your prediction and you can start collecting your data. All right? Again, we shouldn't be starting on the graphing today because I doubt everyone will come up with something and get all their data by the end of the class period. I highly doubt that, right? So I'm going to get this passed.